Hello and welcome to my first video on polynomials. Most of you have probably never heard the word polynomial before, and if I know anything from class, a lot of you will struggle with saying it for a bit, but you'll get used to it. First thing I want to mention is I've written this mathclips.ca up here. We're going to be using Algebra Tiles in this unit, and mathclips.ca has the best algebra tiles online by far. So if you're working from home, that's the website you want to go to. Okay, this lesson's a bit dry. We basically need to learn a bunch of definitions before we can actually start getting into the math. So that's going to be a lot of today. Okay, first one is a variable. I'm sure you've all seen variables before. The variable we usually use is x. And a variable is just a letter that we use to represent a quantity that can change. Vary means change in English, so variable means changeable. So x might be a 6, it might be an 8, it might be a 12, we don't know. Okay, term. This is a brand new definition for you guys, and it's going to seem a bit weird at first, but we'll talk about it. A term is a number multiplied by one or more variables, and those variables need to be raised to a whole power. So either a variable to the power of 0, a variable to the power of 1, a variable to the power of a million. A million would be a whole value because it doesn't have any fractions or decimals. Okay, so let's have a look at example 1. Are these terms? Okay, so is this a number multiplied by a variable to a whole power? Well, 5's a number, so that's good. And when we don't have anything between a number and a variable, that means multiplied, so that's good. And the variable is raised to a whole power. It's raised to the power of 7. So yeah, this is a yes. Okay, next one. X squared. Is that a number multiplied by one or more variables to a whole power? Well, we've definitely got a variable to a whole power. What about the number out front? This is where stuff gets a bit weird. We can think about this as 1 times x squared. So in that way, it's a yes. Notice anything I'm going to be writing in red is kind of the stuff we can think about as being there, but isn't really there. Okay, the next one. Is this a number multiplied by one or more variables raised to whole powers? Okay, well, negative 1/2 is a number. Notice this doesn't need to be a whole number. This just needs to be a number. So negative 1/2 is fine. And then we've got two variables, and they're raised to the power of 2 and 3, so those are whole powers. So yes. Okay, the next one, D. We've got negative 7 times x to the power of 0.5. So we've got a number times a variable. But the power isn't a whole power. It's a decimal, or we could think of it as a fraction. So this guy's a no. All right, E. E, we've just got x. Okay, well, we know from doing B that we can think about this as 1 times x. So that takes care of the number part. What about the whole power part? Well, x is the same as x to the power of 1. Right? X times itself one time is x to the power of 1. So really, we can think about x as 1 times x to the power of 1, which means we've got a number times a variable to a whole power. And notice 1 is on the list. So that guy's a yes. Last one, the weirdest one of all. So even though there's no variable there, they say we can raise the variable to a whole power, and that includes 0. Hopefully you guys remember from last unit that anything to the power of 0 equals 1. So even though there isn't really a variable here, we could think about this as 18 times x to the power of 0. And again, there isn't really an x there, but we want to think about it that way so that we can say that 18 is a term. So notice, anytime we have just a variable, it's a term. Anytime we have just a number, it's a term. Okay, so now that we know what a term is, let's have a look at a polynomial. A polynomial is just one or more terms added together. So in this case, 2y squared, is that a term? Yeah, it's a number times a variable to a whole power. And 3x, is that a term? Yep, that's a number times a variable to a whole power. Remember, this is 3x to the power 1, if we want to think about it that way. So yeah, and they're added together, so yes. And then what are the terms? Okay, so the first term is going to be 2y squared. And then the other term we added to it was 3x. Okay, B, negative 5p. Is that a polynomial? Some people think no at first because there's nothing added together. But notice, a polynomial is one or more terms. So basically, if we've just got one term, it's a polynomial. So in this case, yes. Because negative 5 is a number, and we got p to the power 1. And what's our term? Negative 5p. Okay, C. C, are these terms first off? 17 times x, yeah, that's a term. 3x squared, that's a term. But are they added together? Yes and no. So right now, they're subtracted, not added. But we can rewrite this as addition. So I could rewrite this as 17x. And then instead of taking away 3x squared, I could think of it as giving a 3x squared debt. So 17x minus 3x squared is the same as 17x plus negative 3x squared. And now do we have two polynomials added together? Yes. And what are the terms? One of the terms added together is 17x, and the other term added together is negative 3x squared. When I ask you for the terms on these, you often forget about this negative, because remember, we need to think about it as adding. So if we're adding these two terms, then the terms would have to be 17x and negative 3x squared. So be careful about that. Okay. I want you guys to pause the video now and just read through those definitions there. Okay, so you can either read through them on your sheet or on the screen. All right, I'm going to assume that you've paused the video and read those definitions. If you haven't, the rest of this is going to be very confusing. Okay, and let's complete the table here. So let's have a look at 5x plus 3 first. What variable do we have there? Well, the variable we usually use is x. You remember that's the value that can change. Sometimes x is going to be 3, sometimes it'll be 12. We don't know. Okay, terms. So you remember a polynomial is terms added together. So in this case, we've got 5x as a term and 3 as a term. Okay, coefficient. A coefficient is the number part of a variable term. And a variable term is a term with a variable in it. So basically, we're only looking at 5x, because that's the only variable term. And then the number part of that is 5. So we've only got one coefficient here, 5. Constant term. Constant term is a term without a variable. So in this case, 3. Okay, degree. Degree is the highest number of variables multiplied together. So in this case, we've got one variable. Here we've got 0 variables. So the highest number between 1 and 0 is going to be 1. Okay, and then monomial, binomial, trinomial. And these are easy to remember because it's like a monocle, like Mr. Peanut wears, only has one thing for his eye. Bi is like a bicycle, tri is like a tricycle. So it's basically mono is 1, bi is 2, tri is 3. So in this case, we've got two terms, so it is a binomial. Okay, next column, variables. Here we've got an x and a y, so we've got two variables. Terms. Now remember, we need to think about this as things added together. So I'm going to rewrite this above as 2x squared plus negative 12y plus negative 7. Now it's easy to see our terms are 2x squared, negative 12y, and negative 7. Coefficients. Coefficients are the number parts of the variable terms. So we've only got two variable terms here. One of the numbers on them is 2. The other number is negative 12. Don't forget that negative. Okay, and constant term, that's without a variable, so that's going to be negative 7. Okay, degree, highest number of variables multiplied together. So here I've got x times x is x squared, so this one has 2 variables multiplied together. This is just a y, so it's got 1 variable, and this one has 0 variables. So we've got 2, 1, and 0. The highest between those numbers is 2. Okay, and this time we've got 3 terms, so trinomial. All right, and last one. Well, that's weird. Negative 8. You remember, any number is a polynomial. Okay, variable. I don't see a variable. None. Notice above we talked about the fact that we could think about it as negative 8 times x to the power 0, but the x to the power 0 isn't really there, so there's no variable. Okay, next one, terms. Oh, we've just got one term. Negative 8. Coefficients. Coefficients are the number part of the variable term. Well, there's no variable term, so there's no coefficients. None. Constant term. That's without a variable. And yeah, negative 8 doesn't have a variable, so that term is a constant term. Degree. This has 0 variables multiplied together, so our degree is 0. Notice, up here there's no coefficient, so we say none, which is different than a degree of 0 because we have 0 variables multiplied together. Okay, and last one, 1, 2, or 3 terms, just one, so that's going to be a monomial. Okay, and next page. Okay, algebra tiles. These are algebra tiles. If you were in class, you'd have a bag of them in front of you. One of the sides are either blue, green, or white, and the back side of all of them is red. Okay, so let's have a look at this little guy first here. And I'm just going to trace this onto the page. You guys should be drawing a picture of this. Okay, and notice that little guy has a side length of 1. Well, I guess both side lengths are 1. Okay, which means that the area is going to be length times width, which means our area is going to be 1 times 1, which is, of course, 1. So this little white guy, that algebra tile represents 1. And we're not going to be getting into the length times width stuff right away, but we will eventually, so it's good for you guys to see it. Okay, next one I like to call the green French fry, because it looks like a green French fry. And I'm going to quick draw that on the sheet here so we can talk about it. There we go. And that side length is 1, obviously, because it's the exact same side length as these little guys. They make them like that on purpose. Now the other side, in elementary school you guys might have seen stuff like this, where the other side length was 10. Well, that's like 1, 2, 3, 4. It looks like it's 5 and a bit, maybe. Anyways, they've intentionally designed these so it's not an exact amount of 1s. And we call that side length x. So basically, we don't know how long that side is, but we're just going to call it x. Okay, and our area, again, is going to be length times width. So this time it's going to be 1 times x, and 1 times x is x. So we've got our 1, and we've got our x. Third type and final type is what I like to call big blue, because it's big and it's blue. Okay, I'm going to trace this guy on. There we go. And notice that side length is exactly the same as that. And if that side length was x, then this side length must also be x, which means the area of big blue must be x times x. The lazy way of writing x times x is x squared. So notice we've got 1, we've got x, and we've got x squared. Okay, at the bottom of your page now, I want you to write, I guess we're up to example 4. write these polynomials. Okay, and I want you to write A, B, C, D, and E there. Okay, so I'm going to show you some tiles, and I want you to write down the polynomials for those tiles. And when I'm done, I'll write down the polynomials so you guys can check your work. Okay, so here's A. There it is. There's A. So what polynomial do those tiles represent? Okay, and hit pause if you need to. Okay, next one, B. So here's B. B is just those 3 green French fries. So A is these 5 pieces, B is those 3 green French fries. So write down what polynomial you think those represent. And actually, you know what? Why don't, if you want to pause it while you're doing that, I'll write those down right away. No point in waiting all the way until the end. So A was 5 ones, so it was just 5. B, we had 3 green French fries, or 3 X's, so it's just 3X. Okay, let's make it a little bit harder. C, I'm going to do that. So this time we've got some little white ones and some green French fries. Okay, and pause it if you're not ready. I'm about to write down the answer. This guy is going to be 2x plus 3. So we've got 2 green French fries, 3 little white ones. That guy is 2x plus 3. Okay, next one. So here's D. And yeah, I'm going to have to cover up the D just to make this fit, but you guys know that this is D. Do that. And that. So again, in the space where you've got your D, write down that polynomial. Remember, the red sides are negative. So write down that polynomial. Oh, I didn't tell you guys the red sides were negative yet, I don't think. Anyways, the red sides are negative. Okay, and again, pause it if you're not ready. I'm about to write it down. So this one we've got negative x squared plus, actually let's put that in brackets because it's negative, plus negative 3x, and then just plus 4. And if we want to be a bit lazier about writing that, we can get rid of the brackets and change the adding a negative to a subtraction. So the way the textbook will have this, it'll have it as negative x minus 3x plus 4. Okay, and one more under E. There we go. There we go. So there's E. And even though it's kind of covering up A, B, C, D, I'm just going to tell you this group of tiles here is E. So I want you to write that down. And again, just give it a pause if you're not ready, and I'll write down the answer. So we've got 2 big blues, so that's going to be 2x squared. 1 red x, so plus negative x. You could also write that as negative 1x if you want, also correct. And we've got plus a negative 2. And again, the textbook isn't usually going to write adding a negative. They'll write subtraction instead, so the textbook would have 2x squared minus x minus 2. Okay, so hopefully now you've got some kind of an idea of what a polynomial is and how to use algebra tiles. So we'll be doing some adding, subtracting, and multiplying and dividing of algebra tile, or of polynomials using algebra tiles for the rest of this unit.